Hi, this is my demo of the solar panel stow operate classifier for the Intro to AI class project 1. The idea with this is pretty simple. It's just a classifier that you insert text into. You give a weather description on the current weather, and it tells you if you should stow your panel or you should keep it operating. If it thinks that it can be harmed by the weather, such as hail or wind, it'll say to stow, and otherwise it'll say to keep operating. Under the hood, there's basically 6 trained machine learning models. I trained them from a Jupyter notebook on about 1,450 short casual weather descriptions, and about I think 600-ish scenarios they'd never seen. This Streamlit app just loads these trained models. It does not retrain them. So on the left, I can pick which model I want to feature. The FFNN is just by default. It's also the most accurate with about 90% accuracy. So in the middle, I can type the description. So let's do a good example for what should be a stow. So let's do the example. And as you can see, 6 out of the 6 models reach the same verdict, which is to stow on a 95% confidence. On the right here, you can kind of see some text statistics, words, sentences, average length, and vocabulary richness, which is just the distinct words divided by the total words. Unanimous. All 6 models say stow, 96% accurate, and you can kind of see what words kind of drove this prediction. So hail, roof, my. Usually, if you're saying my, it's something is happening to something that is yours, so that has correlation. Ball, hammering, yeah, and then kind of down here you can see more of the stats, which we'll go over in a second. So let's do a more safe weather description. Let's do kind of basic, but let's try this. As you can see, 99% confident that we should operate. 6 of the 6 models agreed. And you can kind of see what would drive here. So sun, clear, nice day. It's which these kind of have less. It could kind of go either way. But sun is obviously a big one. If the sun is out, it's like the best thing you could have for your solar panels. And then you can kind of see the stats down here for that. Okay, let's do something a little bit more 50-50. So see, this is really 4 of the 6 models with a 67% confident. I was able to get it earlier with 50-50. This is basically what I put in. But anyways, so dark would obviously push to the right. picking to the right, clouds with some to the left. You kind of see the stats down here. So the decision tree was 100% confident, which it would be like just when it reaches one of its leaf nodes. Add a boost is going to be basically 50% on anything. And then kind of see these are a little bit more varied, which the SVM, FFNN, LSTM, and CNN are about 60. This one's a little bit higher at about 90 to stow, so maybe a little bit more conservative. So yeah, we can kind of switch models right here, and the decision might change. This is still 4 out of 6 with about the same things. So the decision tree, yeah, operate, which, yeah, it's only going to say clouds. Add a boost. Kind of see where that's pushing. Not by much, though. LSTM and CNN. So that's basically, oh yes, I can download a summary report right here. I'm not going to do that because you won't be able to see that. But yeah, that's basically my app. Just a clear store operate decision classifier, and gives a little bit of explanation, 6 models that kind of cross check each other, an agreement score that tells you how much you can trust the call. Everything was trained and evaluated in the notebook that will be submitted alongside this. Yeah, thank you for watching. I also forgot to mention, I have a little panel down here basically explaining how these get scored, and you have the accuracy, the precision, the recall, F1, and ROC, AUC, and then you kind of have like the tiers. So clear would just be like a sunny day, like pretty simple, and then implied is basically bad weather, and then borderline is going to be 50-50. It's going to be like the really tough decisions, and that's what this app doesn't really hide. It's not just going to like guess if it's going to be operatable or stow on like a 50-50. It's going to tell you the confidence on that, and it's usually going to be pretty close to 50% on a lot of the hard stuff. And then you have the file upload here as well. Alright, thank you.
Project 2 adds 2 language models, both running locally on the space, no API key. The first is the explainer, a Gwyn 2.5, 1.5 billion model. It turns the model's decision into plain English rationale an operator could act on, grounded only in the weather and the decision, not a free-floating opinion. So I can have something right here, just a description of the weather. So you can see the decision for the FFNN. It just says to stow. But if we go to the large language model, I already clicked this, but it basically generates why it would do that. So the model decided to stow because your home is receiving significant damage due to hail and tornadoes, which poses immediate risk to your property. It's best to tilt the panels flat to avoid further harm. So this decision is made by the machine learning models, not the LLM. But then you have the LLM zero shot verdict, which has to stow, which is kind of separate from this and has probability of 0.56. So not super accurate, but there's still On strong cases, it will be right. On the 50/50s, it's going to be pretty unpredictable. And it'll kind of say that here if this is against all the machine learning models. Okay, let's do kind of a better one that's better weather, like so sunny. See this operate, and then I will run the LLM. So the explanation is model decided to keep the solar panels operating because it detected that it's currently sunny outside with no clouds blocking the sun. This favorable weather condition indicates optimal conditions for energy production without needing to tilt the panels to avoid damage from direct sunlight. And then you also have the independent cross-check from the LLM zero-shot verdict, and it says to operate on a 0.46 probability, which agrees. So let's try to get this to disagree with the language models, or the machine learning models. So let's say slightly cloudy, a little bit of to okay, this is a little bit more 50-50. See, so this says to stow 4 out of 6, but this says to operate. Pretty low probability. So the explanation is, which is separate from this, is that the model predicts high cloud cover and increasing wind speed, which could damage panels if they're still tilted. Stowing the panels will keep them safe until conditions improve, which is pretty accurate. But this zero shot verdict says to operate, and there's a little bit of a warning here. The independent LLM says to operate, disagreeing with the 6th model majority stow. On the test set, the majority was a little bit less reliable when the LLM disagreed, 86 versus 90, where the second looks. So this isn't that's basically saying that this is not too reliable. That's about it. Thank you.